In this graph, we can observe some black circular points. These points, known as test points, allows us to measure different voltages, value, or clock line. On the motherboard, these points have a golden color. They are practically a gold-colored circle. These test points help us to measure the voltage and the data of some important lines. In this way, we can know if the load speed of the battery is correct, also if the power on input is correct, or measure if the CPU protection line is in a good condition. After understanding how the PMIC works, let's go to the schematic diagram to analyze the lines. We are going to look for the boost lines in this model, for example, in the Samsung Galaxy A51. This device is quite modern and current with the launch in March 2020. Here we have the VINB1, which means voltage input in English, voltage input boost 1. Then we continue with the other lines, VINB21, VINB3, VINB4, VINB5, and so on. Always remember voltage input boost 1, boost 2, boost 3, boost 4, and so on. In front of these lines we have a capacitor where we can make the measurements. Here above we can see that all these capacitors are communicating with VBIT sys line. The VBIT line will give the voltage of the battery. If we connect the power laboratory supply to the mobile, we have to have this voltage without having to press the power button. In this device, we'll have these 11 capacitors with the boost voltage. So it has to output 11 voltages, which means that have 11 inductors or bobbin. There is no problem if you don't have a schematic diagram. Just count the number of bobbins to determine the number of inputs and outputs of the PMIC. Normally, when we are measuring these bobbins, a sound will be emitted as if it were grounded, but it will not be shorted. Therefore, to make the measurement correctly, the tester must be used in diode mode. These bobbins can emit sound as if they are grounded, but there are lines that reach the GPU, graphics processing unit, and it is usually given in AMOLED screens. The U5002 interface contains LDO lines, low dropout voltage regulators, and the U5003 interface contains other functions such as the PWR key button. This interface also includes line for the volume button and, as usual, clock lines for correct data transmissions between the circuits. Let's see if the experience changes a lot when we are using a Xiaomi device instead of a Samsung. First, we need to identify the PMIC present in the device. This can be done by looking for an integrated circuit with many bobbins, capacitors around it, and a NURBY oscillator crystal. In the schematic diagram, instead of finding U20011, U20012, U20013, we find letters A, B, C, and so on. These letters represent the interface of the PMIC. As in Samsung, the PMIC has the same numbers of inputs as outputs. In our case, we are going to have 9 output bobbins and 9 input lines, which are the nodes on the left. Also, the same input line, we can have 2 capacitors in parallel. I repeat, all the diagrams are very similar, can change the name of the lines and little more. We just have to get the logic. In Xiaomi, we have different abbreviation than in Samsung, but in reality they are the same. If we have 10 capacitors in the boost line, we have 10 bobbins in the back line. And if we have 8 back bobbin, we have 8 input capacitors and so on.